So let's look at whether or not a relationship is a function, because not all relationships are functions. A relationship is only a function if every input gives exactly one output. If you put something into the relationship and it gives you more than one different answer, then that relationship cannot be called a function. In order to be a function, every input, everything, every value you put into the function can only produce one output. So for example, anything you put in for x, and we call that our independent variable, any value that you plug in for the independent variable, you can remember that because independent starts with in, and it's the value that you're putting into the function. Any value that you put in only gives one value for the dependent variable. What comes out? This depends on what goes in. That's why it's called the dependent variable. So let's look at some tables of values and see if these relationships can be called a function. Because remember, a function means that every input gives exactly one output. So let's look at this first table. Here's all of our inputs because x is going to be our independent variable. So here's all of our inputs, and they're going to give us each of these outputs. 4 gives 1. If we put 6 into whatever this function is, it would give us 3. If we put 2 in, it gives us 2. If we put 8 in, it gives us 12. That means that every single input gives an output. 4 gives 1, 6 gives 3, 2 gives 2, 8 gives 2, 8 gives 12. There is no value of the inputs that gives more than one output. Each is connected to just one thing, one output value. So this is an example of a function. Let's look over here. 2 gives 1, 9 gives 5, 3 gives 4, and 9 gives 2. If you notice, 9 is giving 5, and the input value of 9 is giving 2. So we have one input value, 9, that's producing two different outputs. In order to be a function, every input has to give exactly one output. But here, 9 is giving 2. It's giving 5, and it's giving a 2. So this is not a function. We have one input, 9, giving two different outputs. Now let's look at a graph. The x-axis represents our independent variable. That's all of our inputs. So if we look at all these different values here, and we follow it up to our graph, we can see that each point on the graph represents a different output value for each input. Here's our input, follow it up, that would be the output that it would give. So in this situation, this graph is a function because every different input value we give is going to give a different output. So this is a function. Now look over here. Here we have an input value, but if we follow it up or down, it gives two different output values. So this is not a function. We have one input value giving two different output values. Because this graph represents all the input-output combinations for this function. So this input gives two different outputs. This x value gives two different y values. A nice way to tell if graphs are functions is something called the vertical line test. And what this test means is that if you draw a vertical line anywhere on your graph, it should only cross your graph in one spot, because each vertical line represents an input value right here. And if it only crosses in one spot, it's a function. If it crosses in two, then it's not a function, because every input can only give exactly one output, not two.